So the next talk is similar in spirit. It's from Baidu, who are also talking about industry perspective on benchmarks. And I believe that the first speaker will be Hua. Is that true?
Yeah.
Yep. Okay, good. Thank you. You can go ahead.
Yeah, thank you. So we also talk about benchmarks from an industrial perspective. And Jing and I will talk about it. I will talk the first two. Sorry. The first two parts, and Jing will take the last two. As we know, we have many data sets now. Many are created in a cross-sourcing way, such as SWOT. This kind of data set have accelerated the development of NOPI technologies. Now, the previous technology data set usually in built for linguistics, such as benchmarks for parsing semantic rule labeling. Now, this kind some data sets are built for real applications, such as for dialogue, question answering, and translation. And also, many more benchmarks are created to evaluate generalization capabilities of the models. For example, for glue, soup glue, and were created for testing the understanding capabilities of the models. So, but this kind of more data sets are usually generated in crowdsourcing way. But for real applications, they have different distributions and different challenges. So we need to consider the robustness of the models and the knowledge faithfulness of the models, and also besides the text, the expression, we need to consider multimodal scenarios, and the models sometimes need to use the for different domains. So in real world applications, we need to consider more and more aspects. So we create the many data set for real scenarios. Here we create 14 data sets for information extraction, sentiment analysis, machine translation, dialogue, and question answering. For information extraction, we focus on relation extraction and the event extraction. For sentiment analysis, we focus on trust versus sentiment analysis and multimodal sentiment analysis. For machine translation, we focus on two main challenges. One is for simultaneous translation. The other is for no resource translation. For dialogue, we focus on incorporate knowledge into dialogues for dialogue to make the dialogues or the conversations informative, coherent, and engaging. For question answering, we mainly focus on the real on robustness. And I take the question answering, dialogue, and translation examples. For question answering, we built a Chinese machine reading comprehension dataset. We named it as Do Reader. For Do Reader, this is a machine reading comprehension. Sorry. The question, the documents are also are from Baidu search. Before I go in details of the Do Reader, maybe everyone know machine reading comprehension. I skip here, skip this, and here is the details for DoReader. DoReader, as I say, the questions and documents are from Baidu search. So we have very rich question types. There are fact-related questions and opinion-related questions. So we also classify the questions into entity questions and the description questions and the yes/no questions. As we know, yes/no questions are very difficult for models. And also the documents and answers. The documents for each question we have extract the the answers from multi documents. And now DoReader is the largest Chinese MRC data set. We also organize a share task for this data set. And we besides the DoReader, we also take the hardest the type from the from the data set. For example, we take the yes/no questions and to build a new data set, and for the shared task, we also build a robust new data set to evaluate the robustness of problems of the models. For dialogue, we focus on incorporated knowledge into the dialogue. We take the knowledge graph to lead the conversation to complete the goal. I skip the details here, and for this data, we focused on the system to proactively lead the conversation and incorporate the knowledge to the models for information to construct an informative conversation. We also organize shared tasks for this. And for simultaneous translation, we focused on a multimodal because for simultaneous translation, we need the speech recognition and the text translation. And we focused on Chinese to English. For this task, we main focus the challenge to balance the translation quality and the latency, and also want to design a new evaluation metrics for simultaneous translation. Here's an example of the BXTC simultaneous translation dataset. For one example, we include the Chinese speech and its ASI result, and its transcription, and its English translation. We also have a workshop and for simultaneous translation. Last year, we the first workshop on at ACL, and this year at NACO. Now we have several submissions for this shared task, and we found more and more research on simultaneous translation, and worked on how to keep balance the translation quality and the latency, and also designed a new method to rank these systems. Although we make the efforts to build a more new application data set, but it's not enough. So we want to work together with all of the NLP researchers to work on more data set to focus on the robustness and the faithfulness and the multitask and the multi-domain problems of the models. So we launched a new project named Luger. So Jing will talk about it. Jing?
Yeah. let me continue. So I cannot. So you can stop the sharing.
I stop here and you continue.
So can you see the screen now? Yeah, okay. So yeah, let me continue the last two part. In the last two part, I will quickly go through one open source project and one story that I want to share with you. As Juan talked about in the first two parts, and we have many challenging issues in natural language processing. And so like the open source software, we want to see that if we can create an open source project for the data set, for the benchmark of NLP. So in the last year, we together with many authors of the data sets to create and launch an open source project of Chinese NLP benchmarks, and we call it Look. And in this project, we aim to address the issues of natural language processing, such as robustness, faithfulness, and generalization. And in the current version of Look, we cover rich types of natural language processing tasks, such as language understanding and language generation, and some multi-module tasks. And actually, when we try to start this open source project, we talked to a lot of authors of NLP data sets, and all the authors actually gave us quite positive feedback, and we quickly so that we can quickly launch this open source project. And currently, this project covers 10 tasks and 36 data sets. And for each task, we provide unified data formats and evaluation scripts, which we hope that can help this unified data formats and evaluation scripts can help the students and developers or researchers to quickly start their experience. And this is the 10 tasks currently already in the open source project Look, and such as a dialogue, simultaneous translation, machine reading comprehension, question answering, and so on and so forth. So after we launch this project, and I think it's really useful according to some the usage statistics. This is the statistics of the open source project Look. After we launch it, we have more data sets and tasks added in this project, and the number of downloads and the number of registration is quite high, and I think it helped a lot of students and some developers to learn or develop their own NLP data sets. Yeah, and that's the open source project I want to introduce, which is called Look. And if you want to learn more about Look, you can visit this URL, look.ai, to learn more about the open source project. And besides the open source project, there's another story I want to share with you. That is the robustness of deep learning-based model and the neural network models. So as we know, after the pre-trained language model was invented, such as BERT and ERNIE, so the performance of many natural language processing tasks were hugely improved. And we also tried it in our production. And when we deploy the pre-trained language models based models to our production, and we really observe the huge improvements on many metrics, such as the offline evaluation on some pre-created benchmark, and the online A/B test. So we just launched it to our production. But after we launch it, since we have quite a huge traffic on the production, And sometimes we receive very negative feedback from users, and they just say that, okay, why could you, why can you make such stupid mistakes? And we really look into the cases that reported by our users. And yes, so even though the pre-trained language models significantly have improved the model performance, but sometimes it's not that robust, and it will really hurt the user experience of the production. So then we started a long journey to try to solve this problem in the production. And along with while we were working on this, and we found that actually there's no such good robustness benchmarks so we create such benchmarks, and we shared we would like to share it with the community. So this data set is called Duan for question answering, especially. So we call this data set is linguistically perturbated nature questions for the robustness evaluation of question measuring, and we will share this data set, and this is still not released, but we will hold a shared task in this month, and this data set will be released later. And I think there are two aspects I want to mention of this set. First one is that this data includes fine-grained types with linguistic perturbation. As shown in this table, we really leverage a lot of traditional linguistic tools to create such adversarial examples, and to measure that if the model really really have the capabilities of certain linguistic capabilities. And another aspect I want to mention is that all the adversarial examples are natural questions from our applications, not just the altered text, such as inserting some words or or deleting some words from sentences, which may not be unnatural, which may be unnatural text. And so that's the story I want to share with you. And I think that's all. And that's all of my presentation.
Ellen, I'm not hearing you.
Oh, can you hear me?
Yeah, I hear Jing. Yeah, but I thought Ellen was speaking. No.
I was speaking. I spoke a whole bunch. Can you hear me now?
Yes.
Okay. All right. Sorry about that. So first of all, I thanked the speakers, and then I asked if anybody had any questions, and now this time John does. So go ahead, John. You go ahead, and then I can ask my question later. Go ahead.
So I have to ask. I mean, Chinese and English are pretty different languages. What kinds of things cause you the most trouble in terms of doing translation?
For translation, for simultaneous translation, I think that the most challenging problems are how to keep the latencies very low. As you, so we make much effort to how to develop the models to segment the source sentence into small fragments. For example, we need to design models to wait a few words to for example for Chinese to English, we need to pick up a semantic semantic unit to translate before the speaker finished his sentence.
So John, the problem in Chinese is that the verb tends to be at the end of the sentence. And in English, it tends to be, it's verb second. It's pretty close to the beginning. And what I was saying is that for simultaneous speech-to-speech translation, you want to have low latency.
Yeah.
And I don't want to wait until the entire end of the sentence before I start translating. But it's really difficult to translate if you don't know the verb. So what Wu was saying is that they've got some incredibly amazing things to try to guess what's coming.
Hmm. Interesting. Yeah.
But I think that for the tasks that were being described here, the machine reading things, those are offline tasks, right? You don't have a latency problem.
Yeah.
So like the slide we were looking at before with the negation and the lexical semantics and all that, can you bring that up?
You mean for to read?
This slide, yeah. So this one is not a bilingual task. This is a monolingual Chinese task, right?
Yeah. Yes.
And it's also offline, not online. So latency isn't an issue.
Yeah.
Is that right?
For to reader is not. Yeah.
And is this do reader? I thought this was do QM. Just something else, isn't it?
Yeah, this is we call this is do QM, and this is an offline evaluation benchmark.
Right. So here we don't have the problem of reordering because everything's in Chinese. But some of the problems that are brought up here are classic hard problems in computational linguistics. And one of the really tough problems is negation. You know, so, you know, we were talking about things that are easy and things that are hard. So like in a CAPTCHA, CAPTCHA is sort of like, can you come up with a task that is easy enough that any human can do it, but no machine can? And the task is to separate the man and the machine. And you know, you've all seen the standard CAPTCHAs. So there are some things that you know that are just really, really hard. And one of them would be to look at a lot of pictures and say which ones have street signs and which don't. All right. If there's words embedded in text with all kinds of overlays and stuff, that's really hard for vision guys. Doing something sensible with negation is really tricky. And, you know, I actually have an interesting theory about what's going on there, but, you know, so these problems involving negation are quite tricky. Synonyms and antonyms are a classic problem. The standard methods that we use for both of these is to measure similarity by a co-occurrence and a corpus. So, and the problem is that both things that co-occur in a corpus are things that are comparable, either that you can compare or contrast. And so both synonyms and antonyms are comparable. There's only one bit difference, but it's really hard. All right. I actually have a theory about how to deal with that as well, but so I would expect that most of the standard things we're going to do would say that, in fact, antonyms are probably more similar than synonyms, believe it or not. They're more likely to contrast than you are to compare. The time is, you know, we had a lot of discussion about time in one of the earlier talks. Time is a classic hard problem. Nobody can really do anything with that. I wouldn't have thought that active or passive is hard, but I don't know the Chinese grammar enough. Is it harder in Chinese than in English?
It's hard to measure the difficult, but at least for machine, it's difficult, I think.
Right. Yeah. So is it that in Chinese the word order is
that sample there with for active passive? Were these supposed to be the same sense? Because what should I do if I hit someone is very different from what should I do if I get hit by someone, right? That's not just an active passive difference. It's the meaning is different.
Yeah. I mean, I think right, but it's a lot of the same content words. Like the characters are very similar in both those cases.
Well,
right?
yes, it has lots of, it's lexically very similar, but it means
right.
different things.
So Hong Li, were you about to explain what's going on in the active versus passive? Can you give us a little grammar lesson on Chinese grammar?
To that part, I don't have a strong opinion, but my feeling is that English is rich in singular plural forms and also articles. So if we want to translate Chinese to English, for example, in Chinese, actually, we don't have a rich grammar in plural form, singular form, and also not, like we don't have articles like those in English. So if you translate Chinese to English, and then we have to guess the forms or singular or plural, and also the articles.
And gender is a problem too, isn't it?
Gender is okay because he, she.
Well, on the pronouns it's fine, but I thought you can't tell from people's names whether they're male or female often.
Yeah, that's also, but in Chinese, typically it's okay if you have Chinese characters. Maybe with 90% of the cases you can tell, but you cannot say for sure, but
But the difference between definite and indefinite.
Because recently I translated an article in Chinese to English, and when I look at the English, currently the machine translation system can really do a very good job in translation. Then I check the plural forms, singular forms, and also the articles, and I see a lot of errors. So that's one of the big issues I saw.
So I think a lot of times most languages have things they're similar on and things they're different. And so the thing that's particularly difficult is to introduce information that's not in the source language. So
yes.
The thing about singular and plural and count noun, mass noun, and definite, indefinite, these are all concepts that are important in English but are absent from Chinese. Going the reverse direction, I think there's also many things. So I could believe that this active passive thing is much easier in English than it is in Chinese.
For that, I don't see much challenges there for machine translation. We can easily translate passive voice in English to Chinese and in general.
Okay, so in the example that's down here of the active versus passive, what's the difference between the two strings? It looks like they're very similar characters. It has to do with the third character there. It seems to be different, right?
You mean in Chinese?
Actually, Lori is quite a linguist here, and she's telling us quite a bit on the chat. Lori, why don't you just speak up?
I just wanted to comment on something that you said about things that are present in English but not Chinese. And one of the things you mentioned was definiteness. English and Chinese have different strategies for dealing with information that's old and new, as in it's been mentioned before, or it's familiar to the speaker and hearer or not. So
maybe you need to explain a little bit what given new information.
Oh, okay. So like if you say, I met a student, then student, the first time you mention student is new. And then the next time you mention student, you would say the student. Because it's been mentioned before, so now it's old. So whereas English uses determiners like the and to keep track of what's new and what's old, Chinese also keeps track of what's new and what's old, but in a completely different way. So like if you want to have a subject of a transitive verb like you want to say in English, a student read a book, it would be natural to say a student read a book. But in Chinese, it might be more natural to say exist one student read book. Because it's more normal for subjects of sentences to be old than to be new, like a student that you haven't mentioned before. I'm probably losing everybody here. Anyway, what I'm trying to say is Chinese keeps track of old and new information in
Just
discourse
in a different way than English.
in a completely
Yeah.
different way.
Yes, yes, yes.
Right.
Sometimes
And so
even
this task about active passive is just a very different problem in English and Chinese. And are you sort of saying you wouldn't characterize it as active passive? You'd characterize it as old new or something?
No, well, for this one, I mean, Chinese has something that's called a passive construction, but I would never expect I wouldn't expect it to be like English.
yeah, that's true.
And probably the particle that makes the sentence passive was probably originally a verb historically. So like we're trying to map everything onto English grammar, but it's not comparable. It shouldn't be mapped onto English grammar.
Okay. Anyway, John, I think you got into a whole can of worms here. Ellen, you
No,
better take over.
I've been to China, maybe 10 times or so. And I knew it was not a language I was going to get very far in learning. I tried to learn a few phrases, all right, and I learned to be nervous when they offered Mao Tai, okay, at a banquet. But I just couldn't. I'm very fascinated to see how far you folks have gotten, because those languages are pretty different.
Yeah. No, let's explain how far it is. That is, I go to China now. Well, before COVID, I went 5 times a year. And I regularly attend meetings where I'm the only person in the room that doesn't speak Chinese. And the technology is good enough that I can follow the meeting without any human interpreter. Now, I'm way better off with a human interpreter than I am with a machine, but it's possible for me to participate in a meeting when I don't speak the language, and that would have been unimaginable 5 or 10 years ago, I think.
Yes.
And it's also now the case that if you go into a hotel or anything like that, all the people behind the, working in the hotel are all prepared to deal with people speaking other languages using their phones. Go on, John. I'm sorry I cut you off.
Yeah, I was curious about the computing environments that run these different things. I mean, particularly the low latency translations. What do you use?
Oh, we usually use computers, a PC, or Mac, or cell phone.
No, but that's the user interface. Isn't there something going on in the cloud behind that?
Usually 2 to 3 seconds behind the original speech. Yeah.
No, what I meant is that what's going on in the phone is that it's running an API that's actually doing the heavy lifting in the cloud, isn't it?
Yeah, we need a microphone and
No,
yeah.
I meant that most of there's a GPU running in a cluster.
Oh yeah.
And it's not on the, it's not at the edge, it's in the cloud.
Yeah.
And the methods that are all used these days are all deep nets. They're pretty much all using transformer models. I'll share with you a draft of a paper I'm working on right now that's trying to make deep nets accessible. It's called Deep Nets for Poets. and it's intended for, I wrote a paper about 30 years ago called Unix for Poets, and it was encouraging linguists and lexicographers and translators to use Unix. And I'm working on one right now for deep nets for poets, and it's trying to make all of this stuff really accessible to non-programmers. Now, I also ran it by Brian Kernahan, that you know him, right?
Oh yeah, he and I've written papers together.
Yeah, I thought so. Anyway, he seemed to like it because he's also been in the business of making Unix accessible.
Yeah.
I don't know that it's exactly going to answer your question of what's going on, but this includes enough code that would make it very easy for you to follow what's actually going on underneath the covers, and you can run it all either, you don't need a big heavy, these days I think you can run most of the examples on a standalone workstation, even running Unix or something. I don't think you even need a GPU. It's just that it won't be real time without a GPU.
Okay, we should probably move on now. Thank you very much.
Thank you.
And so now the third talk in the session is from Neville Ryant, and he's going to be talking about diarization, which is a speech task of sort of attributing the utterances to the people who spoke them. So take it away, Neville.
Right, so as Ellen just mentioned, I'll be talking about some work done in the last 3 years on a speech diarization challenge we've been running since 2018. Ellen already alluded to what diarization is, but just very briefly, diarization is often spoken of as the who spoke when task. So to attribute to the turns, the speaker turns in a conversation, the actual speakers that spoke those turns. So this is just here an example of what a perfect diarization would look like for a two-person interview between, this is an excerpt from Fresh Air, between Terry Gross and Willie Nelson. And there's lots of reasons why you might care about diarization, but one specific case that's illustrated here is it simply makes the output of a speech-to-text system much more interpretable to humans, whether they're analysts or more interpretable to a downstream task like dependency parsing or constituency parsing or some sort of natural language understanding task. A lot of work was done under the aegis of this NIST evaluation program from between 2000 and 2009, the Rich Transcription Series. Diarization was only one component of the series. The interest is more generally attributing all kinds of additional metadata that could be useful to humans or to systems. It could be things like finding the edges of sentence units or disfluencies, but 8 of the evaluations had a speaker diarization component, and there was a lot of work that happened and a lot of advancements while this program was active. Then there was an 8-year stretch where there just wasn't really anything going, well, let me rephrase this. There wasn't anything going on at the level of a large multi-year program or evaluation series organized by somebody in industry or in a government program. There were lots of labs working on diarization independently, often on different subsets. So some of them worked on meeting speech, which was the focus of the NIST evaluation series for most of the time that it ran. Some people worked on broadcast news or in conversational telephone speech. But even when you had people working on the same data set, for instance, the AMI meeting domain data set, there are often inconsistent evaluation procedures, not just in terms of the metrics or even if the same metric, how the metric was computed, but even sometimes just what the reference labeling was. With the result, it's just very difficult when you look at the work that was being done in this period to really compare systems and gauge progress. It was clear that improvements were being made, both in the technology that was being used, often borrowed from speech verification literature, and in the outputs, but it wasn't really clear exactly to what degree we're making progress, even on really well-studied domains like the meeting domain. This is where DieHard enters in. So the 2017 JSOLT workshop was, I guess there's been 3 workshops now in the last 4 years at JSOLT, where one of the teams had a diarization focus. but this was the first of those more recent series of diarization teams. So 2017, a group of us, including Ken, were at CMU working on diarization. And one thing that became clear after about 6 weeks of beating our head against the wall was that we really just didn't know what the scope of the problem was. We knew we weren't doing great, but we didn't really know just how badly we were doing or where we needed to really devote additional effort. And to give an example of just, sorry, I deleted that slide. I kind of eviscerated the slide deck to try and make 8 minutes. So I'll just jump over to what DieHard is. So DieHard was the outgrowth of that workshop. It's an intent to try to create, initially, it wasn't intended to replace a DARPA or IARPA or large, well-funded program. It was just intended to get an idea of where exactly we stood by giving us a common framework for evaluating current diarization systems. The focus was on robust diarization. So diarization that was robust to all kinds of variation along all kinds of dimensions, conversational interaction, number of speakers, percentage speech overlap in the conversations, recording and channel conditions, recording conditions, signal to noise ratio, even language. And we've now run DieHard 3 times. The first of these evaluations was run in spring 2018, the most recent just this past year, albeit on a highly modified COVID-related schedule. The task, the metrics, these have been constant across the evaluation series. The data have had minor changes in terms of annotation, which data sets were included, but the task has always been to take the recordings and for each recording, determine how many speakers were present in the recording and identify all the corresponding speech segments. And this task has been evaluated under 2 different tracks. The first, diarization from an Oracle speech segmentation, which was intended to allow evaluation diarization systems independent of the quality of any speech activity detector, which was certainly relevant back before end-to-end systems started to make inroads. And then the second, more realistic track, track 2, which is diarization just from raw audio with no additional side information. And just to give an idea here, I've listed the domains we've chosen from over the years. So this has ranged from this sort of essentially trivial audiobook, single speaker, clean conditions, to various kinds of 2-party conversational interactions, where it's map task or conversational telephone speech or various kinds of clinical interviews, all the way up to extremely difficult interactions such as found video from YouTube and Vimeo, which is a whole range of types of environments you'll see, meeting speech with lots of speakers, and conversations recorded in the wild in restaurants. Thankfully, we actually have seen quite decent reductions in diarization error rate just in the last 3 years. When we first started this, the best performing system for track 1 was achieving a DER, diarization error rate, of nearly 24%, which has been reduced to 13.5% in 3 years, about a 45% relative reduction. And if you look at track 2, we see a similar 45% or so reduction from 35.5% to 19.37%. And for interest of time, I'm not going to go over what diarization error rate actually is, but if you go and look at the much longer full presentation, I do go into this in some detail. There is predictably quite a bit of variation in performance by domain. So this is a representation of performance overall on each track and by domain for all the submissions on the final leaderboard for DieHard 3. We have about a grouping here of domains where I would say there's variation just how hard diarization is, but it looks tractable. And then you have this grouping of meeting speech, web video, and these restaurant conversations where it's really brutal for systems. It's almost unfair really to be evaluating right now. The restaurant speech in particular, the diarization error rate can be north of 55% in the realistic evaluation condition. And just really quickly to kind of recap some of the lessons we've learned. One is that diarization performance has improved drastically. You can still get a really, really large improvement with the right incentives even now. Having said that, it still remains very hard. As I mentioned, in the worst case scenario, we had diarization error rates exceeding 50%, a median of 50%. 50% of the submissions, and these are submissions people have worked on for 12 weeks, were actually still quite a bit worse than that. And this is not just hard for people in academia who are in other groups and institutes that are submitting to DieHard. If you look at commercial APIs to implement diarization, it's also really bad. So I'm not going to play this example, but this is an excerpt from the AMI meeting corpus, and it's actually not a difficult excerpt relative to how meeting speech can be. At the top, we have what a perfect diarization would look like. And at the bottom, we have the output of the IBM Watson speech API in 2021. It's trying to do this who spoke when task, but it's really not a great output. And it doesn't qualitatively feel better than when I ran the exact same snippet through the systems 4 years ago. Also, okay, I'll wrap this up really quickly. We learned predictably that devising a challenge that would actually be fair and then implemented was a lot harder than expected. In particular, we were overly optimistic about what was actually possible with manual annotation for this kind of data. We did do some initial pilot experiments where we were getting real-time rates of 5 to 6 times real-time, but it turns out that the audio, the recordings that are extremely difficult for systems are exceptionally difficult for humans, even extremely well-trained humans who you would think would be able to do quite well in this. I can say personally, I can attest that in some cases, I was spending 31 times real time for some of this child language acquisition data. Diarization error rate may not be the right metric. We actually know it's not the right metric. I mean, it has to be simplified in many ways just to be useful in the context of a challenge and for giving a easily digested performance measure you can plot over time. But in particular, it doesn't gracefully handle scoring. And it's also equally clear that despite the fact we've seen about a 35% relative reduction in diarization error rate over just the last 3 years on meeting speech, it's not at all clear that when you look at the output of commercial APIs for meeting speech, that's noticeably improved in any way that has an impact on how it could be used by a human. And I will just, in about 10 minutes, so I will stop there and field questions.
Okay, thank you. Do we have questions? John?
Yeah, can you go back to that slide that had DieHard 3 Dare by domain?
Yeah. This guy.
Yeah. Can you just go from left to right and say what each of those things is?
Yeah. So to the very far left here, this is just the overall diarization error rate on track. So track 1 in red, that is the more constrained evaluation where you give the systems a lot of help by giving them the Oracle speech segmentation to work off of. So the errors that you see in track 1, unless you've just really not done your job correctly, should only be resulting from confusing 2 speakers or from missing speech. You should not have any kind of false alarms because you've been given a perfect SAD input to the system. And then track 2, which is the much more realistic condition, which was not made the default condition originally just because we didn't know just how hard things really were. So we just wanted to make it a little easier in terms of comparisons. And then you have the domains listed in increasing order of median diarization error rate on track 1. So down here at the very bottom, we have audiobooks. These are excerpts from LibriVox. So they're amateur readers of, in this case, English audiobooks, public domain texts, generally in relatively clean conditions, but there's very inconsistent miking setups. These are amateurs, so people vary in the quality. Occasionally, you might have a non-native speaker, but it should be generally trivial. There is some weird stuff going on in track 1 in this last DieHard. For some reason, some of the systems, this was originally included as a sanity check, but you can see some systems are just not doing something right on this specific.
So here the answer should be there's only one speaker, right?
It should be trivial. If you have in track 1 the reference speech segmentation, which you do, and you can detect that there's one speaker either by doing some sort of domain classification or doing something that's a little more general purpose. We did allow people explicitly, if they wanted to build domain classifiers based on the dev set, they were free to do so. The way the rules were set up, especially for DieHard 1, was a bit of a free fall for all, anything goes. What can we actually do if we let you do almost anything that's reasonable? For instance, you could use proprietary data if you wanted to, as long as you described exactly what you were using.
So if you guess that this is a book, and then books are only read by one speaker, then that's trivial.
It should be. Like the law teams would do something similar to that. This is really just a sanity check. I explicitly include this as a sanity check. Like part of the reason for having all these domains was not just to kind of see, how generalizable are the approaches and how well can we do when we give you something that's objectively really hard. It was just to see what can happen when you don't have side information saying you're constrained to a small set of possible cases. You asked me to go through this figure in more detail. So going to the right quickly, we have this map task is a two-party conversational interaction. It's actually one of the more interesting data sets that LDC has ever published. This is from the Canadian military sleep depriving people for 60 hours and then injecting them with different doses of amphetamines to see what's going on. So they had a lot of tests that they were being administered at regular intervals, but they were also being paired up within each treatment group to do a map task. So it's very clean audio, although the people who are being recorded doing this are sometimes under rather unusual circumstances. But the type of interaction it is, it's a map task, it's cooperative, it's goal-directed, there's not a lot of overlap. You do have back channels predictably occasionally, but it's not something like a six-party interaction where you have massive overlap.
So in this case, one party is trying to explain directions to another party?
Yes. Very conventional map task corpus, very goal-directed. Basically, one party has the map, the other party doesn't. The party with the map has to navigate the other person to a goal from a starting point. Then if we also look at this sort of middle section, I'm just going to note the other two-party interactions. So these social lab and social field recordings, these are interviews that are generally an interviewer and an interviewee. There might occasionally be somebody else who pops in to the recording environment briefly. That's generally two people. The social linguistic lab interviews, these are controlled condition interviews, and it's a social linguistic interview in the style that Bill Above pioneered. So trying to get people to talk about events in their life, things that would induce stress, to try and get them to reveal their idiolect. And then the social field is exactly identical, except these are actually very unconstrained recording conditions. So it's not just that SNR can be degraded, but for instance, some of these have been recorded at a home environment where you have children coming in and out of the room. Some of these are recorded at cafes where it's just a convenient place to record. So you might have reverberation, you have clinking of glasses. So the environment conditions can be, and SNR can be problematic, but and it's informal speech. So sometimes there will be overlaps because Bill, especially as an interviewer, is trying to keep things very informal. But still, it's two-party interaction. The CTS, the conversational telephone speech, this is excerpts from Fisher that were not released. They were collected as part of EARS, but never actually released into the program. So this is unexposed conversational telephone speech.
I don't think everyone would know what Fisher is.
Yeah, okay, yeah. But these are prompted. So these, this is one of the various collections, telephone speech collections LDC has done over the years, where people would phone into a platform and get paired off to discuss, and they'd be given a prompt for what maybe the topic should be, and then it's discussed in this case for 10 minutes. So people might not have familiarity with each other, but they'll have familiarity with this sort of general task. And it does get, it's not too stilted. It feels a bit like a real conversation when you start selecting from these, especially if you have 2,000 hours to select from. So again, you do have characteristics of informal conversation. You have overlap, you have laughter, you have people being disfluent.
You skipped over court.
Yes, I'm doing the two-party interactions together rather than left to right. Then we have the more multi-party interactions where things get dodgier. So sorry, broadcast is also, this is actually not broadcast news. I should clarify, I didn't have the full label in here because otherwise it became hard to read. These are broadcast interviews. So it's just another kind of clean interview, but in this case, it's a different kind of interview. It's informational because these are student-run radio interviews from the 70s conducted by University of Pennsylvania students with people that were considered to be either of interest or to would be of interest. So this is people like Isaac Asimov, for instance, was interviewed by these folks at one point. And as Ken brought up, I skipped over court. So let's get into some of the more interesting ones. So this is Supreme Court of the United States recordings. These are excerpted from the 2001 term because we had very high quality segmentation for that term specifically and very good speaker ID. And so there actually are more people speaking during SCOTUS cases than you might expect, and a lot more overlap than you expect. In the diehard dev data set, I can't remember for the eval, but I assume it's similar. The worst case is a 5-way overlap, which I can tell you, it's not fair for a human to do that, much less a machine. But you do have this kind of overlap. You do have this kind of interactivity, even despite it being courtroom, and it's very reverberant environment. You have the meeting speech, meeting speech and restaurant. These are both multi-party. The meeting speech is similar to the kind of meeting speech that's actually distributed during the RT program, the written transcription program. 4 to 7 people. You have frequent overlap. You have lots of interruptions. The recording conditions are less than ideal. These were frequently meetings that had many microphones. You have close talking microphones, which we did not provide the performers with. You would have various microphone arrays, which were distant microphones, which is what the performers would get a single, what was evaluated to have the best SNR channel from one of those microphone arrays. But often the gain, for whatever reason, was so low during these recordings, you have very bad SNR. The restaurant is similar kind of interaction, but in a much less constrained situation and without a goal. So it's very conversational and there's lots of people, but it could be, for instance, in an environment where you have hard surfaces all over the place, lots of reverberation, lots of echo. Camera seems to have frozen up here. Okay. You can have lots of background conversations sometimes. So it's very challenging. It was included because I just wanted to see what happened if we threw the kitchen sink at originally. It's not, I think, very interesting to look at system performance up here because it basically bludgeoned them over the head to see how bad you can make them perform. I don't think you really drive something at this point. And then we have the web video right here, so I might as well just describe the last of these difficult domains. This is a kind of hodgepodge because it's these were actually selected for us by some folks involved with the VAST program. So it's a combination of Mandarin and English language web video collected from Vimeo and YouTube. And it's just all over the place in terms of the number of speakers, the recording condition. It's honestly, after having spent a bit more time dealing with this kind of video, I'd almost prefer to evaluate web video as a separate challenge because of just how non-homogeneous the contents of this domain are. So it's not at all surprising that it's problematic because it's all over the place in the content, what is going on, but it's universally pretty much hard.
That's great, thanks. It really helps to get a feel for what these things are in a little more detail, yeah.
If you go and look, the slide deck for the full slides are up on the GitHub. And if
Yeah, I've got them.
Yeah, so there's actually sound for each of the examples. There's example clips for each of the domains in there. So you can actually get a feel for what it actually sounds like. I've tried to select examples that are representative not of the speech, but of the difficulties you encounter when working with those individual domains.
I'm sorry.
So has anybody done this kind of thing on a recording of a Zoom meeting like this?
No. So when we started this off, there hadn't really been any kind of concerted evaluation of diarization. There was plenty of work. There were plenty of groups that were working on the same data set year after year. So within the group, it might be an internal consistent methodology. Since then, there are other evaluations that have included diarization component, and thankfully they've done this under the same evaluation conditions we did with the same scoring software. So you can look at people working on diarization of particular kinds of YouTube videos, and for instance, the Vox SRC challenge, in this case, YouTube interviews. People have worked on massively multi-channel data from the Apollo 11 mission. But you've not had anybody working on Zoom. This is something we've discussed, especially because of COVID making us rethink what is feasible to collect in the near future at scale. It certainly has been something we've discussed, doing diarization under a realistic online meeting condition.
I particularly wondered because if there are attributes of the speech that would make it easier to interpret, and one could give online feedback while people were talking, we might actually improve the recordings that one could get out of these.
I mean, certainly if you're familiar with Otter AI, if you really use Otter AI a lot with your own meetings and your own recordings, you can get it to learn individual speakers. And so, of course, a lot of these, so there's been a move towards more use of end-to-end diarization systems in the last year or two. But historically, and still most of the systems have a modular approach where you're doing some sort of segmentation to get speech segments, and then maybe find those to get speech segments that are homogeneous for a single speaker. And then you'll do a representation of the segment into some embedding space, and then do a cluster of the embedding and maybe some sort of post-processing. And so if you're doing that sort of modular system, you're using generally the exact same approaches to speaker embedding that are used in the speaker verification side of things. So if you have more side information that you can build in, for instance, you have a set of known speakers and you have embeddings for those, reference embeddings for those speakers, there's all kinds of things you could do. Similarly, if you can constrain what the microphone setup looks like. So for instance, the Microsoft Azure Speech API does not have diarization available in the general case. But if you use a microphone array of specific kind, then you can enable diarization, and it's tuned to that particular microphone array. It'll do beamforming in a very specific way and all kinds of other things. So the more you can, there's a lot of ways you can cheat to improve things. I mean, it's not really, cheat's not the wrong word. It's not cheating. It's just if you constrain things, you can improve performance even more. Or for example, in this Zoom case specifically, multimodal diarization becomes feasible because presumably in many cases, the people speaking will also have their video on, and they will have a face in there that you could draw a bounding box around, and you can extract features from that bounding box, and you can use that to help.
One of the reasons I ask is I sometimes do oral histories for the Computer History Museum. And, being able to get the text for those things automatically would be good.
So there are some services you should know about. I can point you to them. It's gotten now for people who do podcasts that they regularly use these services. They not only given input as an audio, it outputs a transcript that is pretty good, including the turns. And then a lot of people who are working on podcasts like to post the transcript along with the audio. And there are services now that are actually quite useful for this. Another thing they like to do with that is that these guys like to delete all the filled pauses, the ums and the ahs.
Oh, yeah.
And those services can do that kind of thing too, or at least they make it very easy for someone doing, I don't know what you want to call it, the audio touch-up, to make the interview look a whole lot better. And also to shorten it, because just time is money. So you might actually want to know about some of the things that are going on in that space. There are commercial products you can just buy.
Also, I might know some of the same products Ken is talking about, but if they're anything like Otter AI, for instance, I'll bring up if you're doing oral histories where they're very, very large amount of speech for a specific set of speakers, it is also very, very useful with those where you can enroll those speakers of interest and then have a better, more tailored model throughout the entire corpus.
Yeah, it's not so much that. What typically happens is you sit down with somebody for a couple hours, and there's two of you, and you ask lots of questions. I did the one for Koenig, for example, and again, they're typically 2 or 3 hours and just two
Yeah.
people, but that's the only time you do it with them.
Right. No, but the podcast guys do this all the time. And
Do
I
this,
think
yeah.
what Neville's saying is you enroll them in the first, few minutes of the interview.
Oh,
And
I
then
see.
it does
Okay.
a speaker dependent model for the rest of
Oh,
the
okay. Oh, that's good. Yes, yes.
And if you're willing to do a little bit of special case training like this, it improves a lot of things.
Yeah. Diarization is sort of the worst case for a current system where you're sampling. I mean, this is a small sample from the full cross product of all these dimensions of variation, basically based upon what I could find that was unexposed over 20 plus years of data collection at LDC that had some interesting variation. But it's a much more worst case scenario in that you get no side information. You don't get any sort of information about the number of speakers outside of maybe if you do a domain classifier based on the dev set and you know what the characteristics look like in the dev set. And we promise to roughly try to have a parallel composition between the dev and the eval set. You can do things like that, but it's very unconstrained otherwise. This is sort of the worst case scenario for systems.
So one of the biggest problems with k-means is to know what k is. And so in general with clustering, it's a huge hint if I tell you how many speakers there are. And so in your case where there's just 2 speakers, that would be very useful to know.
Yes, in the Google system for right now, I'm pretty sure the Google system is doing some sort of end-to-end, online end-to-end, because it requires you to specify an upper bound on the number of speakers. And it certainly makes a huge difference if you get that wrong.
Needless to say, I'm very pleased to see a chart that shows the variations.
Well, if you really want to look at this sort of stuff, I am getting ready to dump onto Zenodo the full evaluation output per domain for every recording and every submission.
No, that's probably more than I need. But I'm glad to see that it isn't just a single number someplace. So.
Yeah, the leaderboards during the challenge is reduced to a single overall number per track just to make it easy for people to see what is going on. But we like to break down by domain and give more detailed breakdowns afterwards because there's too much variation otherwise that's being hidden.
So the cocktail party is one of the sort of classic hard problems, and it's probably always going to remain open in the most dramatic case. The reason we got started in the diehard stuff was because I was working at IBM, and at the time we read some of the literature that had kind of declared this to be a solved problem based on some stupid evaluations, and for some stupid reason we believed them, and then we promised to ship a product, and after we made the promise, we did what we could do, but we ran out of time and we knew what we shipped wasn't good enough. And so then sort of plan B was to engage the research community and say, can you guys help us? Because I couldn't go to the well and get more money to get more time and money, time. It just wasn't going to happen. And I get what Neville's saying here is that, it's 4 years later and IBM's still not any better than they were when I left. And that's kind of where we're at. And the reason he got into all this measurement was because we didn't even understand what the issues were. We just knew it wasn't good enough. The best we could do wasn't good enough. Yeah.
Say we still don't. We have ideas of what some of the issues are of the metrics, but because we also fell into we made the mistake of initially promising to run an evaluation on an annual basis, which is just not feasible when you're not a large program. We've kind of gone behind on doing some of the retrospective analysis of challenges until really this year. So we've kept talking about the issues of the metrics, but not really dialing into that.
Yeah, well, I think that trying to do it every year is pretty tough.
Yeah, we're not doing that. For 3 years, we now have probably the best version of that initial data set and initial evaluation. And now it's sort of the point where talking to people to sort of jointly decide, what subtasks do we want to focus on and do something more tractable.
But still, what I like seeing about graphs like this is that one can look at this and say there's certain subdomains in here where there's pretty good progress, right? And there's others that are really tough, and it shows up pretty clearly.
Yes, and then I don't have those figures in here because 17 slides is already pushing it for 8 minutes, to be quite honest. But if you look at the full one, I do have for 3 of the individual domains a similar performance improvement over time being plotted. And you
I saw those, yeah.
Except for the cases where you're already where it's ceiling, like audiobooks, there's a consistent improvement over time. And it's not just consistent improvement for the best starization error rate, which is what those figures show, but if you show it by median, there's also consistent improvement. It's just, it's maybe like a 30-something% relative reduction instead of a 45% relative reduction because the best teams are getting better at a faster rate than the rest of the field.
Okay, Ken, we should probably
Yeah, I hear you.
turn things over to you to end the workshop.
Okay. Well, listen, I
thank you,
really,
Neville.
yeah, Neville, that was really great. Thank you very much. And I also think that it kind of, that is, I find a lot of what Neville's doing sort of more insightful than what's going on with glue. The glue leaderboard just frustrates me that the systems that are at the top I think they figured out a way to gain the metrics and we just don't know how. But anyway, so listen, I think I really appreciate all the effort people put in here. I think the videos, the full talks are on the GitHub and the YouTubes, and I think there's going to get a lot of views eventually. Maybe it takes a little while for that to pick up. What I really wanted to have happen with the diarization project was really just a realization that some of it is doable and some of it is really hard. And I think maybe the same realization is going on for evaluation. That Ellen, I think, probably has, done more evaluation than any of us. And, there's made real progress in some areas, but I think she'll tell us about areas that are really hard. And that's probably true with everything, that some of it we can make progress on and some of it is going to be much harder. I would love to try to find a way to keep the momentum going in some way, and I'm open to suggestions about follow-up discussions. I think I'd like to see more interdisciplinary collaboration like we've had here. And I think that's really valuable. Getting people to talk who don't normally talk and mixing ideas here. I think a lot of the thoughts are been in one field for a long, long time, and other fields are just reinventing it. So a lot of the experience from spec, I think, much of this community is just beginning to struggle with. Questions like, how do you report the variation across cases or across systems, or how do I combine all these things? If I need to do executive math, what's the best way to do it, and so on. What are the pitfalls here? So that probably one of the problems we're having with things like glue is that they put out a set, they find out it's too easy, people nail it, it runs out of headroom, they try to make something hard and it just doesn't survive very long. I think one of the things you were saying about spec is that there was a living body behind it that could change it up over time. So some things got added, some things got retired. I don't see the same thing happening in our community. So I'm all game to, what should next steps be, but I really appreciate the energy that you all put in here. And I think that the YouTube talks and so on are gonna eventually have a real impact. So thank you, everybody.
Thank you. It was a lot of fun.
Yeah. All right. So with that, I guess I'll say good night or good morning or whatever it is. And thanks, everybody. Okay. Anybody have any comments they want to make, or should we I'll just end it here then. Okay. Take care.